We are here to solve a new Leet code problem, that is minimum number of moves to seat everyone. Here in this problem, we have been given two arrays denoting seats and students. The number of seats and students will always be same, and we need to keep seat each students in the seats available. A student can only sit in the can only occupy a seat. Two students cannot occupy the same seat. Suppose here in this test case we have been given seat location as 315, and we have been given student location as 274. Now we have to minimize the number of moves needed to make all students be seated. So how can we do that? So let's say we want to place the student 2 in the number 1. So the minimum number of moves that will be needed is 2 minus 1, that is 1. If I want to place this number 7 students in the seat 3, so the number of moves needed will be 7 minus 3, that is 4. And if you want to keep the student 4 in number 5, so it will be 5 minus 4, that is 1. So if we use this type of arrangement, the total moves will be 1 plus 4 plus 1, that is 6. Can it be further minimized? Can we have another combination that has a number of moves lesser than this? Yes, of course we can. Now if we keep the students 2 in the number 1, it will obviously 2 moves, 1 moves. Now if we keep the student 7, we in earlier approach we place the 7 student in third position, so it was 4. Now if we want to keep the 7th location student in 5th bench, so it will be 7 minus 5, that is 2. And if we want to place the student 4th in the third location, it will be 4 minus 3, that is 1. So the result will be 1 plus 2 plus 1, that is 4, which is lesser than the 6. So it will be the more optimal answer than this. So 4 is the answer for this one. Now by this way we need to calculate the answer. So one naive approach that can come to your mind, that let's say you are at an emergency, you need to hospitalize one patient. Now how will you do it? You need to hospitalize that person in the nearest hospital, right? So you want to find a bench that is kept at the nearest location of the student. So how to do these things? So why not sorting the seats location and student location in the ascending order? So how can you do it? Let's sort the seat number. There's it will after sorting it will be 1, 3, 5, and if you sort the students it will be 2, 4, 7. Now since both of them are sorted, so the corresponding indexes will be the nearest location for the bench for those students, right? It will be the nearest bench for that particular student. So what will be the answer here? Now if we place a student 2 in 1, it will be 1. If you place the student 4, now student 4 nearest bench is the student 3, we can understand from this sorted order, so it will be 1. Now if we want to place the student 7 in a nearest bench, his nearest bench is 5, so it will be 2. So this approach will give you also 4, 1 plus 2 plus 1. So it seems to be a good approach. So let's code these things up. Let's find the size of the, oh man, let's now, since both the arrays will have the same length, it's been given, so let's sort both the arrays. Now we have sorted both, since we have sorted both the arrays, now we have the nearest bench available for a particular student. So take a variable, let's give a proper name. Now let's iterate through this array. Mm. Now let's iterate through this array. Now I need to calculate the absolute differences between these two, between the bench position and the student position. Now let's return this thing. The test case is passed. Yep, the test case passed. Let's try to submit this. Yeah, it got passed. So it was a bit easy solution because if we sort the trick to this problem is to sort the two arrays so that we have the nearest location available for a particular student. So the time complexity of this approach, since we have sorted these things, it will be n log n, and the space complexity is order of 1 because we haven't used any extra space. So it will be the good approach, and it will be a, of course, greedy problem. That is it from me. Thank you.